Hello humans, so we're going to go over 2.1 in this exercise, or this lecture. So translate infix to prefix math, alright? So I'm going to click that, and it's going to generate some problems. So we want to translate this, which is an infix notation, to DrRacket's prefix notation, where the operator is always in the front. Alright? So, see if you can beat me to the problem. You want to get it into this form, right? Type it out. See if you can beat me to the answer. I'm going to go over spoilers in 3, 2, and 1. Alright, so let's see. We're going to open up pair of parentheses, and as we scan from left to right, we see a multiplication out here, and then a subtraction in this green block. So this multiplication needs to be up over here, times. As we go from left to right again, we see this green block. The plus needs to be over to the left. Alright, so let's just do that. Plus 1, 8. Alright, so we encoded this half already. Let's do the other half. So let's see. In this green block, there are two nested sub-expressions. There's a minus over here. That should be in front, so let's do that. I'm going to open a set of parentheses, put minus, and as we go right, we see a 10 plus 1. No, sir, the operator must be in front. So plus 10 and 1. We're going to keep going right. And we see parentheses 5 times 2. So we got to put that in front. So I'm going to open another set of parentheses. And then times 5, 2. Alright, that should be the answer. I'm going to copy and paste this to the answer input box. I'm going to click check. I got it right. Alright. So I'm pretty sure someone's going to realize that, oh, I'll just copy and paste this over here, and then just move all the operators to the right. And the way I structured this exercise here, you can do that and it will get you to the right answer. Of course, that's not what I want you guys to do, because in this exercise, I want you guys to get used to and be very comfortable with parentheses, because this language is really strict about them. They have a meaning, and you can't just willy-nilly just add them everywhere and expect things to work, right? So here's an example where I have too many parentheses. It's highlighted in red, and if we run it, it's going to be an error, right? That's too many. Every opening parentheses must be matched with a closing one, and that's why this is an error, all right? So I'm going to undo this and hit run, and we're back to where we were. Another common error that I see that you'll actually eventually make is you might do this, right? I'm going to wrap this, highlight it, and then do that. Well, what's wrong here if we try to run it? It says function call, expected a function after the open parentheses, but found a part. So again, as I mentioned, always operator right after the opening parenthesis, and then a set of arguments. And of course, this definition is recursive, all right? There is no operator right here. It doesn't make sense, okay? Another problem that you might run into is this, right? Put a 3 here. What's wrong with this? Well, it gives us a really nice error message. It says, expected function call after the open parenthesis, but found a number. So this 3, it's not an operation. You can't 3 this operation. It's not like a verb, all right? It doesn't make sense. So, of course, the answer to this is, well, I got to delete it. So I'm going to delete this parentheses, and I'm going to hit run. No problem. But oh, wait. What's wrong here? Well, at first, I just deleted this parentheses, like right here. After this 3, I said I'll just delete this one parentheses, right? Are you watching? All right. So every time you delete an opening parenthesis, you should look to make sure that you're closing the proper ending parenthesis, right? That's how you do it correctly. Because if you do it the other way, right? Let's see. Do this, and you erase this one, and then you hit run, and then you erase this last part, because that's, what you think would fix it. It does fix it, but this is going to crash in another way. Right, it's going to say times expected at least 2 arguments, but found 1. Multiplication needs at least 1 extra number to be multiplied with. So you created another error. So again, every time you delete an opening parenthesis, you should look to delete the closing one. Right? That's just a few set of parentheses errors that are kind of common. So another thing I want you guys to get used to is sort of wrapping your operations. So let me do an example. Let's do, let's see. 4 times 2 plus 6 times 1. Let's say you were just, trying to write a racket expression and your sort of grade school, how you always wrote math just sort of kicks in. So you're just going to write this out. 4 times 2, and then 6 times 1. You realize, well, I gotta start putting these in front, and that'll fix that problem. So let me just do that. All right. But now notice that we still need to add these operations. So the key insight here is you have to go all the way back left. You have to highlight this whole block, press Shift 9, because that's how you get the parentheses out, and then put a plus right there. Because again, it's always open parenthesis, name of an operator, set of arguments, all right? And then closing parenthesis. Has to follow that structure. So you have to go all the way left and then put that wrapping this block around this plus here, right? It's not accustomed to how you learned basic arithmetic, because what you do in math is you just keep going right? Whatever you do, just don't stop. Just like keep going right. And whenever you find that you have something you need to do that has a higher priority, you just wrap it in parentheses, right? But that's not how racket works. In racket, parentheses are always mandatory, and you can't have too much or too little, and they have to be in this one rule format. Alright? So one question you may or may not have is, why all these parentheses, man? Like, we could have just used Python or JavaScript or some other language and not have to put up with all these parentheses. Well, I can see that is you would have to put up with other things, but that's beside the point. There is a technical reason as to why this language is designed this way, and if you're more curious about that, I can link some articles and videos in the description below so you can check it out for yourself. If you're not an experienced programmer, you're a beginner, well, don't read these articles and stuff because you won't understand until you get more experience. After you get more experience, you can then read these articles and then get, I can see why. In short, it's a trade-off. We're trading off syntactic flexibility for powers. We're getting something back from doing this. We're not getting nothing, right? And that has to do with treating code as data, but I won't go into the details of that. You can find out more here. Alright? Aside from that, you guys already had to learn Pemdas. Remember Pemdas? Pemdas? Right? That is the order of operations for infix notation. Let's say 3 for this, right? Is parentheses, exponents, multiplication, division, addition, and then subtraction. Because if you don't do it this way, we get completely different answers. Because if you do 3 plus 4 first, you get 7. And then times 2, that's going to equal 14. This is wrong. You're supposed to do the multiplication first. And if we do that first, we get an 8, because 4 times 2 is 8. And then we have to add 3. And that gives us 11. A completely different answer just by switching the order of operations. That's why you have to learn Pemdas. In racket, there is no ambiguity. There's only P. There's only parentheses. You can forget about EMDAS, alright? So, to write that down, it's plus 3 times 4 and 2. There is no ambiguity. There's only P. It's very explicit, whereas Pemdas is very implicit. At some point, you had to be drilled the rules of Pemdas until it came naturally. In racket, we just type in parentheses, and it's really clear from a visual point of view that you need to do certain things first. So that's about it for this one. Let's do one more exercise. So I'm going to hit next. Let's do this one. See if you guys can beat me to the solution by writing the infix notation of this problem. I'm going to go over the answers in 3, 2, and 1. Alright. So I'm going to assume that you guys took a swing at it. And here I go. So, as I scan through this and go left to right, I see a plus out here. That is adding these two expressions. So this plus has to go in front. Alright? Then let's do this green block. This first green block. We see a plus, a 1, and then this blue block of 9 minus 2. So we're going to do that. A plus, of 1, and then minus 9, 2. So we're going to keep going right, and we see this block. So that's 10 times another parentheses block with 7 plus 1. So let me just do that. So times 10, and then plus 7, 1. So let me just copy and paste this in. And there we go. Alright, so good luck doing the rest of the 10. If you have any questions, you can put it in the discussion. Once you feel comfortable, you can give yourself a check if you feel comfortable translating infix to prefix math in racket with parentheses. If not, you can sort of warn yourself to revisit the problems, etc. Alright, that's about it for this one, and I will catch you in the next one. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.